So let's go ahead and find the real zeros of this polynomial. We're going to start by listing all the potential real zeros, using the remainder theorem to determine which of them are zeros, using synthetic division to begin to factor, and then factoring the remaining quadratic using either by finding the factors of AC and factoring by grouping, or using the quadratic formula. So in this case, my potential P's are all the factors of 6, so that's plus or minus 1, 2, 3, and 6. My Q in this case, all the factors of my coefficient of 1, which is just 1. So my possible rational zeros are going to be plus or minus 1, plus or minus 2, plus or minus 3, and plus or minus 6. So I always want to start out with the simpler numbers. That's how I like to do it. So let's do f of 1. I get 1 cubed plus 1 squared minus 5 times 1 minus 6, which is going to be 2 minus 11, which is definitely not 0, so we can stop there. If I do f of negative 1, I get negative 1 cubed plus negative 1 squared minus 5 times negative 1 minus 6. So I get a negative 1 plus 1, okay, starting to look promising, plus 5 minus 6. Well, that's going to give me negative 1 minus 6 is negative 7, plus 6 is a negative 1. Okay, again, not a 0. Let's do 2. F of 2 is 2 cubed, which is 8, plus 4 minus 10 minus 6. Again, that's definitely not going to equal 0. That's a negative 4. And now we're getting frustrated, but let's try this again. F of negative 2 gives me negative 8 plus 4 plus 10 minus 6 by substituting a negative 2 into f of x. And that gives me 0. Ding, ding, ding. We have a winner. So let's use synthetic division, because I know negative 2 is a 0. So I have negative 2. We're going to divide x cubed plus 1x minus 5 minus 6. We pull down that first term. 1 times negative 2 is a negative 2. 1 and negative 2 is negative 1. Negative 1 times 2 is 2. Negative 5 and 2 is a negative 3. Negative 2 times negative 3 is a positive 6 with a remainder of 0, which we knew we were going to get. So this is my remaining polynomial. I have f of x factors into x minus a negative k, so x plus 2, times x squared minus x minus 3. So now I want to factor this, and I say, okay, what are the factors of AC that add up to b? Well, are there any factors of negative 3 that add up to negative 1? No. I wanted to find the real zeros. That doesn't mean they're not going to be all rational, right? I can have some irrational zeros. So we're going to have to use the quadratic formula. A is 1, B is negative 1, C is negative 3. So I have x equals negative b, so 1, plus or minus the square root of b squared minus 4ac all over 2a. That gives me 1 plus or minus the square root of 13 over 2 is x. Those are my zeros. 1 plus the square root of 13 over 2 and 1 minus the square root of 13. So all my zeros are x is negative 2, x is 1/2 plus square root of 13 over 2, and x is 1/2 minus the square root of 13 over 2. Now you might say, Miss Miller, these two zeros are not in my list of potential rational zeros, right? This isn't the list of all possible zeros. This is the list of rational zeros, okay? So let's work through another example from top to bottom.